Hello, here you can see a model of solar on-grid plant that has been made on Vijeo Citect, that is a product of Schneider Electric. I want to start off with by explaining a few things, what they mean. This is the distribution network. Mainly our supply for homes and offices comes from here. It is owned by the government. The, these two are circuit breakers that are used for protection. The size of this system has been minimized for simulation purposes. This is a common bus that is connected to the grid, the solar plant, and the load. The load has been depicted in a form of motor, which has a rotor, and when the load is running, you could actually see the rotor is rotating. This is a solar plant whose capacity is 125 kilowatts. That means that at 1000 meter square of solar radiation, watt per meter square of solar radiation, this plant can supply a maximum power of 125 kilowatts. Here I've written a few things in different colors, and these all things pertain to this particular transmission line that is connected to the grid. Pink means that you will see this is a button that turns on the main supply. These buttons are used to uh, see what is the condition, what is the condition of solar output and solar output. Solar output has been calculated on the basis of solar radiation that is given by the sun at any point of time during the day. The time has been sampled into 24 different buttons for 24 different hours. This is a button for to turn on the solar plant. These buttons are used to adjust the load that is running at any amount of time. The main concept behind on-grid solar plant is that although grid could supply any amount of load, you have to get it sanctioned from the electric utility, from the uh, PSPCL as in the case of Patiala. Uh, the main advantage of solar on-grid plant is that at any point of time when you have fulfilled the requirements of your load and there is some extra power left, you could supply that power back to the grid, and this power could in turn uh, generate revenues for you, or compensate the charges that you have incurred by using the electricity supplied by the grid. Now let us start the simulation. The solar plant has been turned on. The green means that all the lines are active now. You can see that the color is pink. This is because there's no load uh, that has been connected to the grid right now. There's no load demand for the grid actually. Now, when I click this button, we can see that the load has changed to 10 kilowatts, and you can actually see the rotor of the motor is rotating. Now the grid is supplying whole of the 10 kilowatt to our load. Now next I switch on the solar plant. You can see that this transmission line has turned green, which means that solar plant is also capable of supplying power to the grid. We start seeing solar radiation at around 7 or 8 p.m. in Patiala. So based on based on radiation during the day, solar output can be calculated using a formula. So at, let's say, 8 o'clock, we see that the solar plant can supply a total power of 64.03. Now 50 the load is only 10 kilowatts and it could be easily satisfied by the power supplied by the solar plant. But the remaining power is not wasted and hence it is supplied back to the grid, which is represented by orange color. This is all about the simulation. One precautionary measure we have to take that when the grid is off, the whole of the system has to be off because there cannot be any back supply in case any maintenance work is going on this stretch. This could harm the maintenance personnel. Thank you.